Hi everyone. This code defines two functions to check if two numbers are co-prime and allows the user to interactively test pairs of two integers for co-primality. Uh, the first function here I defined as co-prime of A and B, where these functions take two integers A and B as parameters, and it uses an inner function GCD of xy to calculate the greatest common divisor of two variables A and B. The main function returns true if GCD value equal to 1, or else it will return as false. The next function here I have defined as coprime test loop. Here, functions run as an interactive loop where the user is prompted to enter two integer values and uh, catches a potential value error exception if the enter numbers yeah, are if the enter numbers are non-integer values. It then calls the coprime function to check if the enter numbers are coprime and prints out the result. It also prompts user if they wish to enter the another pair of numbers, and the loop continues until the user decides to exit. The user repeatedly input pairs of integers and receive feedback on whether the numbers are coprime or not. This code leverages the Euclidean algorithm to efficiently determine the coprimality and provides an user-friendly interface for testing various number pairs. The coprime of A and B function is efficiently determines whether two numbers A and B are coprime by calculating the greatest common divisor using the Euclidean algorithm. The GCD is computed using the inner function GCD of xy. The use of Euclidean algorithm ensures the efficient GCD calculation, and function terminates when GCD becomes 1, indicating coprimality. The code optimally uses GCD of x and y function from a math model for GCD computation, enhancing the efficiency and reliability. Efforts toward the needless computation. The function terminates as soon as the GCD equals to 1, avoiding unnecessary computation behind this point. The GCD calculation here itself is optimized through Euclidean algorithm, reducing the number of steps required. This implementation ensures the computational efficiency and minimizes the unnecessary condition. The code assumes that the user will input valid integers when prompted. It expects the user to follow the instruction and enter numerical values, and it also catches value error exception for non-integer values. However, the code ex- does not handle explicitly cases where the user might extremely large numbers that could lead to memory or perform issues. If the numbers provided by the users are too large, the GCD calculation could take considerable amount of time, potentially affecting the program responsiveness. Here I'm going to run the code. Um, Here it prompts for the first number. I'll be taking it as 13. The second number is 14. As 13 and 14 has are coprime, which means the GCD equal to 1. So it is those two numbers are coprime. So let test for another numbers. Let me take by if I wish to continue to enter the another two numbers, I enter as yes, and it takes to another pair of numbers. Like I'll be taking as 32, and the second number is 36. 36, as these two numbers are not coprime, it returns as not coprime. And if I wish to take the another number, it moves to the another pair. So I'll be giving output as some string value. So it will throw an exception, invalid input. Please enter integer. So it wants another number as an integer. I'll take 23 and 24 as this is our coprams. These 20 integers prompts as coprime. The result prompts as a coprime. And if I want to exceed now, I'll be writing here as no and returns as exceed. Thank you.